Hey, hello. This is Sudarshan. Can you guys hear me?
Yes, yes, sir. Welcome, sir.
Yeah. Uh, I think can we get started?
Yes, sir.
Hey, hi. I also have Shivani. Shivani,
Uh,
are you
y- 1 minute, sir. I introduced both of you.
sure?
Okay. Welcome to second session of day 3. We have with us two speakers who will conduct hands-on session, Mr. Sudarshan Krishna Kumar and Miss Shivani. Sudarshan Krishna Kumar is MTech graduate from IIT Madras. He has over 5 years of experience on big data technologies and has worked on multiple technologies like Hive, Pig, Uzi, Sparks, HBase and Kafka. Currently, he works with Visa Cards Bangalore. His areas of interest include big data and machine learning. And Miss Shivani, she is a BTech from Motilal Nehru National Institute of Technology, Allahabad. She is currently working with Visa Cards Bangalore. In her journey with Visa, she has developed a tool to generate test data using generative adversarial networks. She has explored Hadoop framework and primarily worked on Spark in her project. She is very keen on exploring and learning about new advancement in the field of deep learning. I request Mr. Sudarshan sir to take over the session. Thank you.
Unmute, sir. Sir, you are not audible.
Hello, Sudarshan sir.
Yeah, I was just saying like this is going to be a session taken by both Shivani and me. I'm just checking. Shivani, are you there?
Yeah, hi Suresh. Yeah, hi everyone.
Yeah, Shivani. Can you share your screen? I think we can.
Sure.
I think I see a big audience. I didn't know like how many people would be joining, and it's a sort of a pleasure for us to kind of present something. To be frank, like this is just a. I mean, we are not like a trained sort of a trainers. I think most of the people I see here are like proper teachers and professors who have been teaching. I kind of respect them. This is like sort of a this is just a very basic things that what we explore and which we can share in the organizational perspective, like what exactly how and what all things we should be knowing about it. It's more with respect to that, and it's not going to be more uh, on a sense of how it needs to be taught in a classroom. It's going to be more like hands-on. I might kind of, because you might have already had some sessions on this, I'm just going to kind of refresh certain things. I want it to be more interactive, like if there are any things, if anyone can kind of put it on chat or anything, that would also be really helpful. I think Shivani and Sudesh, myself, like we both have been working for almost last 1.5 years, 2 years, and she is also very keen to learn new things. And we try to explore new things. Even at Visa, we kind of explore new things, how things can be done differently. So that's our main goal. So let's get started. Shivani, can we go to the next slide? Yeah. Uh, I just want to know, like, I think you had your previous sessions. So I just want to know, like, what do you understand by Hadoop? Anyone, they can just unmute and they can kind of give some information, like, I mean, they want to give their opinion, like, what is Hadoop according to them?
Hadoop is a framework which is used to store the big data sets.
Okay. What is big data then? I mean, like, why a term called big data?
Because nowadays we are dealing with a huge amount of data as from the websites like Instagram, Facebook, or the shopping sites. We are daily, day by day, or we can say per second, we are generating more data, like the hitting for the particular search or any Facebook comment. So this type of data storing.
Okay, so I think finally it comes down to those three V's, or in today's term they call it with a five V's, right?
Yes.
Anyone know about those five V's? I mean, these are like classroom things that people generally talk about. Um, Anyone can tell about the five V's?
Is it volume, velocity, variety,
Okay,
Veracity.
veracity, and what is the last V?
veracity,
Yeah, what is last V?
Value.
Value. Value.
Yeah. So, I mean, first three, I think everyone can understand with the name. What are the last two V's? I mean, what is the, I mean, what is veracity and value?
veracity actually talks about the heterogeneous structure of the data.
Okay. So the veracity is not heterogeneous data. I think that is variety.
Quality
Veracity
of
means
data.
what? Yeah,
Quality of data.
exactly. So I think it's not about just having the data, right? You need to have a good quality data. Say like I'm just having all the comments, but what is the value? I mean, what is the whether they are in same language or if they are in a mixed language? These are certain factors which are going to kind of be very important. Say generally you have all the Facebook chats. Can you start analyzing it directly? Because most of the context, if you see, we will write something like English or in Tanglish or any like a mixed languages. Can anyone kind of process it and directly use it? Not really, right? So you need to kind of have also the data to be in a high quality to kind of use it. And the next point also is important. Like you need to make it used for a some good use cases. I mean, having just this data and just store it is not a sort of a thing that we want to kind of do in our new world. We might have data in gigabyte, petabyte, zettabyte, and so on, like any new bytes, whatever comes up. But we need to make use of it in a very useful way. That is very, very important. And Hadoop is a basic framework which kind of helps in getting all these things done for you. First, Hadoop makes use of like a cheaper what do you say cheaper infrastructure, and how we can use this cheaper infrastructure to scale our problem. That is the more scope of it. uh, I mean, it is good that it was open source. I mean, if it would have been something like not open source, I think accessibility would have been a problem. I mean, it kind of makes use of a lot of other factors, which brings it to be more useful for end users to see. I think we will look at some of these concepts, like whatever features that Hadoop is trying to bring. I'm not like a proper teacher. I'm just giving some high level points. Uh, Most of these things you would have kind of already seen. So, Shivani, let's go to the next slide. Okay. Uh, okay. So what are the basic components that we are having in Hadoop? That's what we are trying to cover here. Uh, what is HDFS? Anyone can try. I mean, what is the difference between a HDFS and YAN? I know that you had a session, so I'm expecting like you would have kind of gone through this. I'm just not. I'm just trying to make it more interactive. Then we can have more sort of proper questions that we can kind of go through it. Anyone who wants to kind of answer, like, what is the difference between a HDFS and a YAN? Okay, HDFS is a Hadoop file system. I here get a ping from Jyoti. Okay, and what about YAN? At least tell what is the expansion for YAN.
HD
Someone was saying HDFS. Okay, Jan is correct. It's yet another resource negotiator. So basically, when you look at Hadoop framework, right, you have these three main components. Uh, First is HDFS. The second is YAN, and the third one is a MapReduce. You can consider them as like a storage layer. HDFS is a storage layer which is with sole responsibilities. How do we store the data? How that needs to be taken care. While the YAN is how you would manage the system. Like you have different resources, how you would want to manage those resources that you are having. And the MapReduce is going to be a core component which would say like how you want to compute it. With respect to HDFS, HDFS is a master slave topology. I saw someone had written it. Yes, right. And what as a first stage it tries to do is, given an input data, it breaks down into multiple blocks and stores it in a different location. A, a simple quick question, like why do we need to break the file into multiple blocks? Why can't we process it as a single large file? Can anyone answer? I mean, we can just store it in as a single part, why it needs to be kind of, I mean, you would have kind of learned about this, right? It kind of breaks it into different blocks and it tries to process. Accessing fast, okay. Decomposition, okay. What are you trying to achieve?
Because if all data means if we don't require the whole data, then there is no use of accessing the whole file. So we can decompose the file, and whichever or whatever data we needed, so only that component we can access.
Okay, I mean, basically you could filter a certain part of it and you can kind of, and finally the important part is distributed processing, right? You don't want to kind of if everything was a responsibility on one single node, you would not be able to distribute the data. You have to kind of distribute the data. So that's where you need to kind of have the data to be split and kind of made it available in multiple blocks in different locations. That's where you would have read about something called as locality principle and other things, right? Okay.
Yes.
Other things which you need to understand is it's with respect to the name nodes and data nodes. Um, uh, in a simple file system, I mean, any Unix file system that you are having, you would have read about the inodes. How many of you have kind of taken the operating system course? You would have kind of clearly seen that there is something concept of inodes and the file structure. I mean, it's not like a distributed system, but within that itself, you had something called as inode, right?
Yes.
That,
Information node.
yes, it maintains a metadata, which is like where, which blocks, I mean, which directory is going to present it, what disk location, other things. The similar concept comes in the distributed file system, where we have something called as name node. The name node acts like a metadata for complete data that you are having in your system. Okay. And there are two parts within the name nodes. One is the FS image and the edit log. The FS image is like a snapshot of whatever is the changes, like whatever, which location is present, which file block is present where, those informations are stored in FS image. Whereas the edit log is sort of a regular updates. An analogy for that would be something like uh, something which is like specifically stored in the I'm just thinking what would be a better analogy I can give for the FS image and edit logs. Basically FS image is something like a snapshot, like what I have, and whereas edit log is any changes or any update on top of the FS image is what you would have it in edit log. Okay. And as I said, it's a master slave architecture. If master goes down, like just think like every college has a principal, right? And if and every other staffs are taken care by the principal. What if the principal is not available? Who's going to take care of the college, right? So we need a way of kind of seeing that there is a standby node. Okay, there is two concept. Prior to 2.0 there was something called a secondary name node, which was more like an active and passive sort of architecture, where once the active name node goes down, this everything has, I mean, a copy of it is kept in the secondary name node. Whereas and once the active name node, we try to restart it, by that time we copy it from the secondary name node to the active name node and start it up. So that was a sort of a architecture that was there prior. But we don't want a system like that, right? In a production system like a Google or anything, if one day you're not able to access file, you'll feel the heat, right? Or like you just want, I just wanted to present, I mean, this is on a Google presentation only, and if when I'm just presenting at that time, if I'm not able to access, that's not what I want. So we always have something called as a standby name node. So this is a high availability feature that Hadoop internally provides. So how it works is basically it uses something called as journal nodes. We will talk about journal nodes when I think the next slide when I will talk about Zookeeper, I will talk about it. But uh, I mean, you can consider like there are some sort of a metadata and all, which kind of has a which helps in synchronizing between the primary name node and the standby name node. Okay. Any questions so far? Okay. Um, okay. If not, I will kind of go to Yarn. I will just briefly tell you like what is Yarn. Uh, okay. I mean, before we go there, everywhere we start, right, you will see this master slave architecture. Do you know any sort of a system which is not a master slave? Anyone can give example? Hello. I think someone is on unmute and talking within himself. Anyone know about Cassandra? Hello. Okay. So Cassandra is like it's again a distributed processing system, which is not like a Hadoop framework. It's not centralized. Like everything from master slave architecture you would not find. Cassandra is a decentralized network where each and every node are uniform. There is nothing like a master node and a slave node. Everything is like a equal node, and everything kind of interacts with each other to ensure that the distributed processing happens in a I mean, in a necessary way. So you guys can kind of read about it, but these are like, I mean, whatever we are talking is not the end of the world. There are a lot of other things which happens around the world. So let's get back to Yarn. So Yarn is like a resource manager. I have already talked about it. It internally has a scheduler to see like how I want to kind of manage the resources. Not all application needs to given a same priority. Some application have to run with a higher priority. Some application have to run with a lower priority. Let's say we have a client node. From client node, we are kind of submitting an application. And if that application needs to be executed, I can kind of make all my responsibility onto the client. Say like client will interact with my resource manager, and it will try to get the necessary resource, and it will talk with the name node and get all the list of nodes where my input data is present. Everything can be managed by the client. But if it was something like that, I mean, just think of a college, right? I mean, everything was done by a principal. You don't need a professor, right? Everything was taught by a principal. You don't need a professor. So I think it's more like a delegation. So we have something similar. We call it as application master. For each and every application, we have something called as application master. So when you launch a job, that particular job is being the responsibility of that is being taken care by the application manager. And there is another reason for it. If everything is being done at the client end, it would become more like um, heavyweight processes running on the client, and that's not what any organization want to have. We will come to that when we talk about like how we want to do in today's world. Most of the processing happens on a sort of a cloud sort of environment, and we would try to keep most of the things as a lightweight operation in our edge node or in our client systems. So anything like if anyone wants to request anything, they would not have any sort of this management or a resource management, other things to be running on their laptop or anything. It's something which would be like a request which goes to application master, and application master takes care of it. It's just that it waits till the final results come to the system. Okay, so basically the clients will be live. That's what just wanted to mention here. Okay. Any questions? I mean, am I going very fast or very slow? I mean, you can give comments. I'm also looking at your comments and trying to go along with it. If not, I think we'll go to the next slide.
What is the role of slaves in this?
Okay, I thought good question. So the slaves is where, so with respect to resources, slaves are the places where the actual job gets executed. With respect to data node, that's where the data is actually being stored. So in name node, you don't store the actual business data. Say you have a CSV file, it will be split into multiple blocks and it will be stored in the data node. It will not be stored in the name node. Okay. Similarly,
Okay.
if you are doing any processing, your processing is not going to happen in either of resource manager or application master. It's just going to happen on the node manager, which is a slave. Uh, did I make a point? Any question?
Yes, sir.
Sir, is it Apache Hadoop will be taking care of mapper and reducer programs? Is it the mapper and reducer are is similar to your master and slave? What you are talking about?
We'll come to MapReduce. I think we have a separate set of slides. Mapper and reducer are different. This is a high level abstraction on top of that. Mapper and reducer are on what you want to execute. So say let's I will come to that. That is nothing you can just consider like a programming paradigm. Map and reduce is sort of a programming paradigm, or it's a library, whereas this is a framework. I hope you understand the difference between a framework and a library. Any other question? Okay, Shivani, I think someone asked about shared edit log. Anything specific you want to understand on shared edit log? Sheetal, I think your voice is breaking. Okay, let's kind of discuss on it at the end. If let's kind of move ahead. Okay, I think we talked about HDFS and Yarn. MapReduce, as I said, it's a programming paradigm. Uh, I think we'll have some sample demo on how to write a MapReduce code, and also I will talk about it there. With respect to Zookeeper, as I said, right, when it was a turn for name node, we have to manage like which name node is going to be active. So we need a sort of a synchronization service. Can anyone like give an example, like how do you synchronize like two processes are running? How do you ensure like only one process runs one job? I mean, uh, uh, in a basic operating system, how do you ensure like only one process is running? You
Critical
kind
sections.
of, can you come again?
Critical sections.
Yes, and in a very simple layman's term,
Semaphore.
semaphores, logs. These are things that you talk about, right? We need similar such things to be there to ensure that only one name node is active at a time. If just think of a scenario like if there are two principals in a college, what would happen? It's more in that aspect. So whenever you want to kind of maintain any synchronization, Zookeeper offers a what do you say, a sort of a abstraction layer where it just maintains a configuration on a distributed sort of a distributed ledger, not a ledger, but a distributed environment where uh, you need to kind of get a lock like who wants to kind of process it and accordingly kind of respond to it. It maintains like which is like the active name node. Similarly, like if there are like hive service running in high HA mode, then which is a hive metastore, which is going to be the active metastore and things like that. So Zookeeper is more like a coordination system that we have in any Hadoop environment. Okay, the next thing, I mean, when you look at MapReduce, right, MapReduce is a sort of a way how you would kind of do the computation. I have already told that MapReduce is more with respect to how do you do the computation. Similarly, in a MapReduce, you write a Java code, or I think there are libraries available on Python also where you can write a MapReduce code. When it comes to Hive, Hive is more with respect to like, I mean, you can look at the MapReduce code and you'll see that these are like uh, like 200 lines of code you would write. Just a simple operation, you will write a 200 lines of code. But the same operation with a Hive, you can just run implement with one query. So Hive is more like just like the way you have a RDBMS system, right? In an RDBMS system, the basic interface that you have to process is through a SQL query. So Hive uses that same principle. It uses the SQL interface to kind of execute the data. I mean, do the processing. Say like even in Hive, you have different engines. You have Spark as an engine. You have Taze as an engine. There are like different set of engines which can be used to process the data. But what Hive does, it kind of expects the data to be uh, processed using a SQL interface. So you build table, so you have a HDFS data. Basically, you store some sort of a CSV files on HDFS. You build a table on top of it. Basically, to say, like, say you have a transactional table, okay, and you build, you know that at this location the files are present. You build a table on top of it and say, I want to process this particular table. Okay, that's what Hive will help you do it. And these are mostly used on an analytical sort of a systems where you want to kind of see like how many, I mean, we will kind of look at certain examples which will make you clear. Okay, so Hive is more with respect to sort of a SQL sort of an interface that you would be having. And so in Hive, there is one basic component called as metastore. How many of you have used MySQL database? Like any RDBMS database that you are aware of, like MySQL or anything?
Yes, we are aware.
Okay, so there is a schema called information schema or my information schema or something like that, right? There is a, so what does it have? It has something called, I mean, we call it as metadata. Have you guys heard about that term? So it's basically the information of the table itself you are keeping. So something similar to that terms we kind of have in Hive. So Hive maintains those metadata in a table, in a RDBMS table. So that is kind of again present in either a MySQL table. So any information like this is a table structure. This table structure reads the data from this HDFS location. All these things are maintained in that metadata or a meta store. I will kind of quickly come, then we'll quickly start on the demonstration. The problem with Hive is new language you can consider where you can write scripts not in a form of a analytical way or like a SQL basis. Rather, you will write like first do this sort of first do this computation. Say you want to filter the record, you will filter the record. Once you filter the record, do the next step. Say once filtering is done, I want to do a aggregation. Once aggregation is done, I want to kind of join it with other tables. All these things can be kind of defined in Pig. And in Pig, it doesn't just do the computation, it also does things lazily. So when you say filter it, it will not filter at that time. Unless you kind of write or unless you store the data, it will just wait so that it can do the operation much more efficiently. It's, I mean, you guys would have kind of heard about something like cost based optimization in RDBMS. How many guys are aware of it? I think these are like core concepts that you will read in computer science. Yeah, so it's similar to that. It kind of utilizes, it sees like what sort of data that I have. Based on that, should I kind of do the filtering operation first, or should I kind of do the join operation first? These all things it will try to consider and then kind of do the processing. So Pig is like a one step ahead. with respect to Hive, and Pig is just for that sake. Like when there is a concept called data pipelines. When you come into any organization, you want to write a code which is well maintained or a clean code, so that any changes that you want to do, you can kind of manage. Uh, I can kind of cut short other things. I will talk very quickly about the other things. I think these are the few things I will cover, like Giraffe, Flink, HBase. I'll quickly. Giraffe is more like a graph-based, graph sort of a data structure where you want to query. I think it is implemented based on Pregel, which is developed by Google, whereas Giraffe was open sourced into Apache community by Facebook. And Flink is more like a it's more used with respect to sort of a streaming sort of application where you have a source data and the target data, and you want to kind of there is a concept of source and a sink, and you kind of copy the data from source to the target. In between, you want to do any operations. HBase is little interesting. It's a NoSQL base. It comes under a category called column oriented storage. uh, I would just at this point I just want to add one point. How many of you know indexes? Anyone know what is indexes in because HBase is based out of indexes. uh, why do we need indexes in any relational database?
To reduce the search time.
Reduce the search time. um, what other things it will help? Just search or any other things it will? How about update? Will it help or not? Okay, integrity, that's there. So HBase uses the indexing concepts. It is based out of a paper called Big Table from Google, and what it tries to do is it tries to build a huge indexes. And if you want to do a HBase is more preferred when you have a range-based queries, or and you want to do a faster update and a faster access, and you would be able to scale faster. So that is these are the certain aspects when HBase is more preferred. So you guys can read about it, and these are like the most of these things whatever I've talked has is been present in the ecosystem for almost 10 years. I would say at least 7+ years for sure. All these systems are there 7+ years. Shivani, any if not any question, let's go to the next slide. Okay. How many of you are aware of cloud computing? Do you think the world is moving towards cloud? What are the reason? Anyone wants?
Cloud is on-demand service. Cloud is on-demand service.
Okay. It's on demand, right? What is the advantage? Like, what is a benefit an end user is going to get? It's not any, nothing is free of cost. uh, okay, you mean the initial setup you don't have to do. Okay, huge storage, you can store data space. The main problem that we have in our current environment is like if we want to kind of set up an organization, right? uh, Nowadays we are looking on how we can build startups, right? In an environment of a startups, if everyone wants to kind of invest on uh, creating every infrastructure from scratch, it's just going to be difficult. And everyone wants to be very what do you say, uh, they want to kind of quickly start up. And the initial time that they, say if you want to build a campus and other things, like even now the I'm not sure, like all these things is because of the cloud. even the Zoom conference we are able to do. If it's not like our college is having a server, they are hosting it and we are kind of getting, right? It's there on cloud. That's why we are able to do it. I mean, we don't have to worry about uh, like having an infrastructure for it. If you just think like few years back, or like 5 to 6 years back, most of the things that we would be thinking is we need to build a server, have a server, we need to host it, we need to have, then we could have a video conferencing. But today it's more like we want to kind of start as fast as possible. Other thing is, we might not be utilizing it fully. That's where pay as you go is something very critical. And pay as you go is very very critical, because if you're not utilizing the cluster, why do you need the cluster? You could kind of just process it, compute it, and store it in a low cost hardware where which you can easily get it, a simple hard drives, and those things can be much more possible. Say if you want to kind of get a sentiment analysis on a huge Twitter data, are you going to do it on a daily basis? Say think about a research, you don't need it on a daily basis. I will just pay it for a time that I want, and I will just kind of let it go. That's how you look at it, right? So that's how uh, all these things like a cloud computing and other things are coming into play. Okay, Shivani, next slide. So in our case, we are using Amazon EC2 instance. EC2 stands for Elastic Cloud Compute, and I think Amazon has done a fantabulous job on different web service that they have made it available. And EC2 is one of the compute engines that they have kind of provisions where we can kind of host certain servers, and we can kind of build a small cluster, and we can kind of give a I mean, we are planning to kind of give a demo on EC2 instance. So Amazon EC2, why Amazon EC2? It's just a choice. And this is something which we also tried. This is also not something we were kind of having it from scratch. EC2, Amazon EC2, there was a micro instances which are available free. You need to configure it. We will talk about it, what all configuration you had to go through. And but the current demo we will be showing is on an Amazon EC2 instance. Just be careful. They will, even though they tell it it's free, you will be charged for it. So be careful when you are kind of choosing options, and you are kind of making the decision you want to do it. So you read about it. I think these are like certain things. You don't have to wait for your college. There was time when we used to wait. I mean, my project was on deep learning, where we used to request for GPUs for all our cloud for all our computation. And since I was doing video classification in my college, I had to wait till the servers were available. Not every time you will be kind of having that. Now with the sort of Amazon EC2 instances, your research can be much more faster. I mean, you can kind of make it run, you can just execute it and get back your resources. I mean, so you don't have to kind of own that server every time. So these are advantages that you are going to get. There are a lot of other services which are available on Amazon. I'm not uh, uh, just trying to sell it. It's just like you can try it out. It just gives you different things that are available on the environment. So Shivani, next slide. I think Shivani will give a demo. Just wanted to tell, like, this is going to be a 4-node cluster that we are building. We are going to have one name node, and I think the name node is also going to have, is also going to have the secondary name node. Because we have a limited set of resources, we kind of shuffled our resources here and there. We are going to have 2 data nodes and a client node. A client node is just a lightweight node from where all the processing is going to happen, whereas the name nodes, data nodes are going to be the ones where you are having the resources or where you are having the services running. So I think we have a basic set of services which are required. I think Shivani will cover on that aspect. I will hand it over to Shivani. Shivani, can you start?
Yeah, hi everyone. Are you able to hear me?
Yes.
Yes, ma'am.
Okay, so I'll start. So as Sudarshan discussed, we have set up a cluster on EC2. That's a 4-node cluster. So I'll start. Okay, so I'll start with discussing the configurations which we did for this cluster.
Ma'am, is it not visible? So please, can you increase its font?
Sure. Now is it visible?
Yes, yes.
Okay, yeah. So at this location, like this Hadoop home is my Hadoop installation directory, and then inside it, etc Hadoop, we'll be having all the configuration files. So among this, one is core site.xml. So here we have all our core configurations. Like basically, this is to tell all the nodes the location of the name node. So as you can see that I've configured what is the name node. So this same configuration will be having on data node as well as client node. So it will kind of inform them, okay, so this is the name node. And other than this, we can also have other configuration settings like IO settings, any security settings or proxy settings also we can have in this core.site.xml, core-site.xml file. Then the next one is HDFS site XML. So here we have HDFS related properties. So the one is the DFS replication. So basically, in Hadoop, what we do like whenever we store a block in multiple places. So for example, like if there's a block which I stored in data node 1 and in case it goes down, so I have a replica available in the data node 2. So this is a replication factor that each block will be stored at 2 places. And the other property is the
Shivani,
yeah.
people, so few people are saying that it's not visible. For me, I can see it. Anyone have any?
Uh, is it very small?
What is installed is what they are asking. I think since she is presenting, it's going to be hard for her. Uh, if you can tell it on mic, I think it will really be helpful. Shivani, I think just give them like, can you start from start, like saying like where is the Apache Hadoop
Okay.
installed, and just let's start from there. Let's just
Okay. So yeah, I'll start from starting. Yeah, so first of all, there is a Apache Hadoop tar file which we get. So we can get it in Apache downloads. So after downloading it, we can untar it to a folder, and inside this folder, we have all the configuration in etc Hadoop. So there we need to change 4 files. The one is core site.xml for core properties. The next one is hdfs site.xml for the properties related to hdfs. Then yarn site.xml, and the last one is map, that is for mapreduce site.xml. These are the 4 files which will be changing, and there are 2 more files, that is masters and workers file. So as we can understand from name, masters file will have the master node, that is the name node, and the workers are the data nodes, so data node 1 and data node 2. And then other than that, we have one more file, that is Hadoop environment.sh. So this is to configure Hadoop environment, like the Java home, like where we have installed Java. So that we can configure here. And there are other properties also, but for our cluster, we just needed to configure Java home. Any questions? Okay, I'll move forward. So, yeah, I'll continue with the HDFS So, yeah, we discussed replication factor, and the next thing is that we'll tell the property that where exactly our data will be stored. Like basically, like this is a EC2 instance, and this is a kind of a Linux box. So here at some location, I'll be storing all the name node data. So we have to configure that path also. So this is, and we can store other HDFS properties also, like authentication or security related properties. Also, we can set in this HDFS site.xml file. Then the next is yarn. So here we set the URL for resource manager. So here we have configured a name node as only as the resource manager, and we have also configured the shuffle services and the shuffle class. So we'll be talking about shuffle in a while, that exactly what it is and how we use it. So we can configure those services also here. Okay, so now we move on to starting a cluster. Okay, so in this folder, in our Hadoop installation directory /sbin, we have all the startup related files. Like when we want to start our name node and data node services and our yarn services, and we also have files for stopping the services. Yeah, so I'm starting all the services.
So you can see, okay, I think name node was already running, Shani.
Yeah, I think properties are already, these name node data nodes were already running. Yeah, but basically it tries to start name nodes and then data nodes, then secondary name node, and then resource manager and node manager.
So if you actually see like where the name node is starting, it's starting on a different host. We are running it from a name node. We are starting all the process on name node, but the jobs are getting started on the respective data nodes.
Yeah. So if we log on to one of the data nodes, yeah, and we can use this JPS command to see what all processes are running. So we can see that data node and node manager is running on the data nodes. And similarly, when we go to name node, we see that name node is running, secondary name node and resource manager. These services are running. So now I'll be starting the history server where we'll store the history of all the applications which we have run. So now I'll move on to some of the HDFS commands which we can run. So one is Hadoop, HDFS admin, -report. So this is to get the state of the cluster and like basically to know about what's the status of data nodes and everything. Like as an report of the cluster we can get through this command.
So this is like a administrative command. This is not going to be something like all users would be going to do. It's just an administrative command that we have. Deepali, I think you have any concern? You have any question? Shivani, did the cluster go into safe mode?
No, actually it's not even safe mode, but it's a bit slow. Let me retry once.
Anyone have any questions? Like we can kind of take. I think this is taking a little while. Just try it from a client node, Shivani.
Okay.
I mean, are you guys able to follow it? Any queries or concerns that you are having?
Okay.
Let me DFS admission. Yeah. Can you, Shivani, can you just, I think I'm not sure why it is, okay, it came.
Yeah. So the results came. So yeah, basically it tells us property like what is the configured capacity of a cluster and what is the present capacity, how much memory and file system is remaining and how much is used. And other than that, we have the status of data nodes. Like we have two live data nodes, data node 1 and data node 2. And what's their host name, and again the same properties like how much of the file system memory is used and how much is remaining, and like these sorts of things we have.
I think one thing which we didn't talk about is we said like we got a EC2 instance. We didn't give the spec of it. The EC2 instance that we got are like two disk, which are like with 8 GB hard disk space and 1 GB RAM. So basically, we kind of what do you say? We kind of configure to kind of use the complete disk space, and that's where you're seeing 8 GB plus 8 GB, 16 GB as a total space of the cluster.
Yes, so we'll move on to the next thing. Like if we want to get the data nodes, the name nodes of a cluster, so we can use this HDFS get conf hyphen name nodes. So this will give us the name node host names. Like this is the name node for a cluster, so it will get us that. Now, basically, HDF is also a file system, so we can do all the things which we do on a Linux file system. We can we can check all the files there by doing HDFS DFS hyphen ls slash. So it lists all the files which we have there. And then if you want to make a new directory, so we can do hdfs dfs hyphen mkdir slash new directory. So as you can see that We have a new directory here. Now we can also transfer the data from a local file system to HDFS and from HDFS to a local file system. So let's say I create a file vi transfer HDFS in my local. And to transfer this, I'll do HDFS DFS -put the file name in my local system, then the location where I want to put it in HDFS. So let's say I want to put it in new directory. Yeah. So if I go and check on new directory in HDFS, we see this file is there, and if we get contents of it, yeah, so it's the one we transfer from our local to HDFS. Now, if we want to get a file from HDFS to our local, we can use get command. So that will be HDFS DFS -get. Now, the name of the file in HDFS along with the path. So I want to transfer this file, demo get from HDFS to my local, to my current directory. So we have this file here. Yeah. So basically, like all the commands which we do in your normal Linux file system, you can do in HDFS as well. So now we'll move on to map reduce.
Shivani, before I just have a question. Can you go back to that screen? Guys, I'm not seeing any response from you guys. I'll just ask you some question. I want it to be more interactive. See, she created a directory, new directory now. It says the timestamp 712. Can anyone answer why so? Are you guys there? Hello? So my question is, I see Shivani had created a directory, new directory now, but the timestamp it shows is 712, which means 712 a.m. So what is it? Which, I mean, I have taken my server as US East. So I mean, US East zone is it like 23rd September? Today is 23rd September, but in US East, I don't think they are still on 22nd September. In some places, they would be. Just check like where exactly it is 712 now.
Actually, I think it's the time in GMT.
I know that. I'm just trying to see.
Sorry, I thought.
Okay, so basically it's a Greenwich Meridian time. Most of the servers that we get, right, it can be configured. Like when you're configuring in the Amazon EC2, we configured for the GMT timing. So that's where you see it in with respect to that. Okay, so it's more for that reason. Shani, you want to open the resource manager and name node manager UI?
Yes. So basically, this is the UI for a name node. So we get an overview of our name node and the summary of like all the details about the capacity and the live nodes, dead nodes, decommission nodes, like each all these details we get here and the status of all the data nodes as well as name nodes. Then we also have this data node tab where we can individually look at the status of each data node. And we also have a resource manager UI. So yeah, here you can see all the applications which are either in any of the state, like in new state or in which are submitted or which are running. Like all these things, we can see that all applications are running on a cluster, and we can also see details about the nodes and about the scheduler.
So when there is a talk of nodes, in case of a resource manager, it talks about the resources, right? How many containers are available? How many process can it run? Whereas when we talk in the HDFS, it talks about the data nodes. So there is that difference that you need to understand. So one is configured with respect to node managers and another with respect to the data nodes. Okay. Okay. Surely, let's go to Emma.
Yeah.
Uh, okay. I think someone was asking about word count or like how a map reduce code actually works, or like what is the difference between a map reduce and a yarn. So as I said, map reduce is a library. Yarn is a framework. I mean, you kind of yarn manages how you want to. Hello, someone have any question? Okay. So MapReduce is just a library which helps you kind of compute certain big data processing uh, in a more simpler way. How many of you are can you guys like tell me like different paradigms of programming that you are aware of? Anyone know about greedy programming? Hello, you guys there? Anyone know about dynamic programming? So, what exactly? I mean, when we say dynamic programming, we would be solving those problems and all, right? In a greedy problem, we kind of try to find a greedy optimal solution in that with a greedy logic, right? So, similar to this, there is one more thing called as divide and conquer. So that's the same sort of a concept that we try to do here. Uses Python uses dynamic. Okay, so we use something called as divide and conquer. So the complete data that we are going to get, we will divide it into multiple input splits, and each of these input splits are going to be processed by a initial set of job called as mappers. That's where the term map has come. So mapper process, it takes a key key value pair of data and kind of emits a key value pair output. So for example, the input data is been split into four parts in this word count example, where the first split is welcome to Hadoop, which is like one line of the data. And in during the mapping process, we generated multiple key value pair for it. So for welcome, so I think just to kind of give you a brief, what is a word count problem? Given a paragraph or a sentence, you would want to know like what are the words and what are the counts with respect to each word, right? I think this is a very common example that everyone understands. So in this case of mapping, right, the input goes as a welcome to Hadoop. Output would be welcome, comma one, 2 comma 1. So we break the sentence into words and each word is having a count of 1, right? Once the mapping is done, we need to send these values to the reducer. How do we send this value to reducer? You guys can see something shuffling, right? Why do we need a shuffler? Anyone can kind of try to answer?
Similar words in one bucket.
Okay, and there is a concept for it. You guys can say that
Clustering.
clustering. Similar to that, another word is there. I mean, discrete mathematics, you have something called as
Association.
partitioning, right? You need to kind of partition this data. I mean, when the output is getting ejected, it could be in this example, you can just consider, will I have, how many reducer would I be having? So for each and every type, will there be one separate reducer? That is not a right thing, right? Say here I have key to be output values which are getting evicted are welcome to Hadoop, class Hadoop, but I don't have these many resources. I only have like 3 reducers that I can run. So in that case I need to kind of partition it, or you kind of called it you, I think you get you told something called as clustering. I mean, clustering is also something like similar things going into one side, right? And it would not be like one entry is present in 2 places. You are just having a hard boundary. That's why it is called partitioning. Okay, clustering, it can be like, it can be fuzzy sometimes. It can be present here and there. But partitioning, it's a clear cut separation between set A and set B, right? So we kind of partition the data, and each partition, I mean, from each of these mapper process, it goes to the respective partition. And once that data is there available on that partition, it needs to be sorted, because the first mapper can kind of send n data points, second mapper can give n data points, but they might have it in a different orders. All the data needs to be brought in a similar ordering. So that's where you need something called as sorting. So a partitioning plus sorting is what happens as a shuffling phase in any map reduce program. So as I said, it's a library which runs on the Hadoop and Yarn framework, where it kind of distributes the data, does the mapping operation, then it does the partitioning, does the sorting, and then reduce it. So what is a reduce operation? You kind of aggregate, right? I mean, it's like you have 3 records, say Hadoop comma 1, Hadoop comma 1. All these needs to be unified into one record, which is Hadoop comma 3, right? So that's what is happens in reducer phase. I will just ask you one point. So, for example, I just want to see if anyone can kind of answer it. Say the second line is Hadoop class Hadoop is. Rather than class Hadoop is, there is something called Hadoop class Hadoop is. So, what would be the output of mapping? I mean, at this particular stage, right? I mean, class Hadoop is in the map output right now. It is class comma 1, Hadoop comma 1, and is comma 1.
Will be Hadoop comma 1, class comma 1, Hadoop comma 1, each comma 1.
Okay, so if you think like in mapping phase, if you have such a replication, the network transfer would be, I mean, you need to, I mean, this is like a replicated set of same values, right? If you would have kind of, instead of making Hadoop comma one, Hadoop comma one twice, if you could have made it as Hadoop comma two, would that kind of optimize your performance?
Yes.
So for the same purpose, in MapReduce paradigm, there is something called as combiner, which is a sort of a reduce operation which happens on the map side, so that the Hadoop comma 2 we can kind of generate and we can optimize the processing. Okay, let's take one example. I mean, we'll try to run a MapReduce program in the cluster and we'll see. Shivani, can you kind of give a demo for the same? Shivani, I think you're on mute.
Hi. So basically, using MapReduce, we'll be solving a problem. We have a sales data where we have the transaction rate information, like the product, its price, and then, sorry, payment type, the name of customer, city, state, and the country where it was sold. So from this data, what we're trying to extract is the number of products sold in each country. So for this, we have a MapReduce code in Java.
बैठ नहीं रहे ना रोज, काम हुए ना, हफ्ते रस एक करे तो थकवाए।
So we have a driver class and one mapper class.
अच्छा वो करने का कुछ नहीं सोच रहे।
I think someone is on. So we have a driver class, a reducer class, and a mapper class. So
घंटा मारा मारा पर नहीं सुने यार, थकवावे यार।
Prasad, can you go on mute?
जरी जवानी असेल तरी मार दुखी।
Shivani, continue.
okay, so I'll start with the driver class.
अबे कोई नहीं।
In driver class, we'll have our initial settings, as in like we'll get a job client.
नहीं 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 मैंने बस उरे उरे जरा जीव शांत करून दे।
नहीं नहीं busy अब।
Prasad Bora, I think you need to kind of go on.
आज काम नहीं मिले प्रसाद।
हाँ तो उन्हें के लिए हुआ काम कर।
Shivani, I think it's muted.
Okay, yeah, I'll continue. So yeah, in the driver class, we have the initial settings sort of thing. So we'll first get a job client, and then we'll set the class class file which we'll be using, and then we'll be setting a job name, and then we'll be specify the data type of we'll set the specify the data type of output. Output key class and output value class. And then in our code, we'll set our mapper class and reducer class. So we'll have sales country dot sales mapper as a mapper class and sales country reducer as a reducer class. Then we'll specify our input format and our output format class. And then we'll set the paths of our input and our output. And then finally, after setting all these configurations, we'll run a job. So basically, we'll call this driver class and we'll pass to it argument for our input directory, where our input data is here, and the output directory where we want to store our output file. Now I'll explain mapper class. So the input to our mapper will be a row from a CSV file. So it will be something like this. And the output, it will output like country name, comma, value of 1. So it will be like key value pairs. So basically, a mapper class needs to extend MapReduce base and should implement a mapper class, and it should have a map method. So first what we'll do, we'll split a value string, that is this row from the CSV file with the delimiter comma, and then we'll map the string, the seventh element of the array to 1. Like seventh element is basically the country element, so we'll map it to 1. So basically we'll be converting that row into key value pairs. And then the output of mapper will go on to the reducer. In reducer class, basically what we'll be doing, like this will be some sort of input which will be there to our reducer class, like country and their values. So what we'll do in reducer class, basically we'll take a key, and for all the values in that key, we'll kind of sum it. So basically, yeah, we'll kind of sum all the values for a particular key, and then we'll give it as the output. So basically, like similar to the mapper class, reducer class also needs to extend from MapReduce base, and it should implement reducer, and it should have a reduce method. So any questions for one code?
So I'll just reiterate one point earlier. So you saw in case of mapper, she is trying to run, she's trying to read for each and every line. So in case of mapper, the input is like the map method is called for each line, right? So basically, she has a transaction record a comma something, uh, second record something. So for each line, she is trying to run the map output process. In case of reducer, it is for each output key she is trying to reduce. So for example, if there is say country, say India, there will not be like two entries for country India. There will be just one entry India, and all the values which are associated to that will be as part of values. Do I make sense? Any questions there? Because that's something which you need to understand. So every time we call a reduce operation, that is all going to be controlled by the map reduce base program that is there. It will try to call it for each and every key. That is like completely abstracted out for us. Like we are just have to write a program to say for each key how I need to implement. That is the logic that is mentioned in this reduce part.
If we have to in map program while mapping, is it required to use combiner to avoid duplicate records?
We can do it in this examples. We haven't kind of included that. We can do that combiner part. It's similar to the reducer part. There is something called as combiner, and in the driver we need to kind of configure that. Did I answer your question? But this is very important. I think in my experience, I've seen a lot of people making this mistake of not understanding the reduce operation. That's why I just wanted to kind of give. Anyone who has written a map reduce code, can you guys tell me there is map reduce 1.0 and 2.0? Is this map reduce 1.0 or 2.0? Anyone who has experience? Okay, I'll just give you an answer. It's basically an old API, so it's a 1.0 API. That's what is being used. It's a sample example. That's why. Okay, Shivani, you can go ahead.
So I've compiled these files to a jar. Now I'll be running this jar. So I can do Hadoop jar and then name of the jar and then the argument, that is the input and the output directory. So I'll run it. So now as we see, we have got an application ID for a running application. So we'll go and check on the UI. The job is starting, so maybe it will take a while to load. So basically from UI, it gives us an easy interface to check all our jobs. So let's say we have multiple jobs running, so we can check all at once through UI and we need not check individual jobs.
I think file already exists, Josh. Or what happened?
So I think there's some connection exception. I think I need to restart name node.
So name node went down.
Yeah.
I think the full path.
Huh?
I think someone has put like the full path. Are you asking for the full path for the application?
Yes, I'm trying to restart the name node.
Yeah, one second, Kavita. I think should be should. So the reason why this UI is very important is in real world the problems will not get solved in like 5 seconds or 10 seconds. The jobs will run for days. I mean, even in our environment, we have things which is running for days, like more than 24 hours. And in that case, if we want to kind of monitor the progress and things like that, sometimes it happens like one of the nodes goes into fail state, and it happens many times. There are a lot of other concepts. There is concept of data skew. When you are doing a shuffling, if all the data goes to one node, it will all be affected, like the complete processing will get impacted because of that. That's something which I mean, you cannot directly get it by just having the data. When you have something like a UI, you will notice like okay, one particular node has been running for almost like the 30 to 40 hours. Something wrong with that, or like only one, I mean, only one node taking a lot more time to kind of process. These are certain aspects that kind of gives you an idea like what has happened like in the cluster. It's taking so much time. I think, to be frank, like we got a very, I mean, it's just a 1 GB RAM. It's not even worth any of your mobile, might be a Nokia mobile. I think we just got it as a low cost, this thing. I think that's what is troubling here.
Yeah.
Yeah, Vinesh, you have any question? Let's give a few minutes. So, meanwhile, I think while this starts up, Shivani, can we go to the presentation? We will kind of come back and to the results and show. I get started with the. Let's get into the Spark also. We'll kind of talk about the Spark and. So, how many of you have heard about Spark? Hello, anyone who has heard about Spark? Okay. If you actually look onto the outside world, most of the people have kind of come out of MapReduce. Okay, anywhere you go and check, the only thing they will talk about is Spark. So we need to understand what is the limitation for MapReduce. So uh, to say like Spark also runs on a HDFS, it uses the yarn based resource negotiator and things like that. That is true. But Hadoop's main problem is when you have something like a iterative computation. Say I need to do certain processing, then before it goes to the next step, you kind of write it into a disk. Every time you do any processing, you read the data from the disk, write the data into the disk, then again read the data from the disk and write back the data into the disk. That has been the that's how uh, Hadoop MapReduce works, and this is something which is not cost effective. Shivani, just see if you're not switching, because when you're switching, I think it is just getting showed up. Okay, so in place of that, what Spark uses is a sort of a distributed memory. The distributed memory concept had come from Hadoop 2.0. What it tries to do is it tries to read the data. If there are like multiple stage of like if there are like multiple phases of task, it just tries to compute one operation after the other and other things like that. So it doesn't need to write the data back into the disk. It does all the computation and finally stores the data. So if there are like if it's a long iterative chain, right, you don't need to do. I mean, how many have you have run any neural networks? Any yes sir or any yeses? You might be knowing about the back propagation, right? Where every time you need to kind of get the result for the forward network, you need to kind of recompute everything. The sort of operation we call it as an iterative computation. You need to read the data A, from A you need to feed back the output to back to A again, and that way you kind of compute the weights of intermediate nodes. In that case, just think about MapReduce. Every time your output results needs to be stored into the disk, then again repopulate the weight and again compute it. Those sort of things would be really inefficient. That's where Spark plays a very vital role, and it kind of makes the processing happen more in a in-memory way, which improves the performance of Spark when you compare it with MapReduce almost 100 times on all cases. So that's why you can just Google it. MapReduce is obsoleted. That's what you will see. There are a lot of blogs which talks about why MapReduce is not something which is a go-ahead solution. Rather, Spark is a something which is more favorable. this is really important. I think people should kind of look on this aspect of Spark, uh, and they should kind of jump into the Spark as soon as possible. You need to know the basics of how MapReduce works, but internally Spark also tries to uh, what do you say, process in a way which is like in a MapReduce paradigm. But we need to jump into this latest technology of Spark. I think it's not even latest, it's even that even Spark is almost 7 years old. So we need to kind of adopt Spark as a processing, because there is a lot of inefficient processing which is happening in MapReduce. Shivani, can we go to the next slide? So what happens in a Spark, right? So a driver or a client program kind of requests the cluster manager. In this case, just consider Yarn is your cluster manager, because the reason why this cluster manager is a separate entity is because there are Spark and all are integrated more with the more cloud-based solution. There are some things like Mesos and other things where the cluster manager would be different. But I think since you guys are very much aware about the Hadoop as a framework, cluster manager would be something similar to Yarn. Okay. And a driver program comes in, you kind of create a Spark context. You request and you create a Spark context for that JVM. You cannot have multiple Spark contexts within a JVM. You will just have one Spark context. Once that Spark context is formed, you kind of create a DAG, which is to represent the set of tasks that you are giving. I mean, we will show a Scala based code which kind of tells like what are all the operations that you are doing. It will convert that into a form of a DAG. Even DAG we will try to kind of demonstrate. I think it depends on the cluster how it is going to happen. Once DAG is built, we kind of build or like split the DAGs into multiple stages. Why do we need that? So for example, we read the data and we need to shuffle. So when there is a shuffling happening, right, when there is a map to between map and reduce, there is a shuffle operation which is happening. Whenever things like that happens, you need to have a new different stage, because until the previous stage complete, you cannot go to the next stage. A very simple example would be doing a join. You need to read the data from two tables and do a processing. If the two tables are a sort of a RDD, so in case of a Spark, the basic data structure you can consider is RDD. It's a logical unit that you are having. So once the RDD1 and RDD2 are available, then only you can go for the next set of RDDs. So whenever there is, it kind of builds a stages, and each stage is kind of separated based on if there are any shuffle operations, and all these stages are scheduled on the task scheduler. So in this case, for example, RDD1 would be processed, RDD2 would be processed. They can be processed in parallelly. It created two tasks for it, and RDD and next two RDDs can be combined into one task, and it will be kind of getting processed. So you kind of divide your each and every DAG, you kind of break it into multiple tasks and then process it. And once the tasks are available, you kind of schedule them onto the different executor nodes or like worker nodes, where I mean it's the same concept like resource manager and a node manager. The resource manager is your cluster manager, and the node manager is your worker node, or the worker node or the executor process. So that the cluster manager can schedule multiple tasks onto that particular node managers. That's what is being demonstrated as a pictorial way. Okay, and there are a lot other things. I think we will kind of, when we demo, I think I can kind of parallelly explain. Shivan, is the cluster back? Once.
Yeah, it is back.
Sorry, Shivani. I think I just got dropped. Can you guys?
Yeah, I'll just continue. Actually, it's back, but it's a bit slow. So,
Shivani, just if you can start on the Spark, we will
okay.
start. If this is taking more time, we'll just start the Spark part. Okay.
Yeah, okay. By the time I can show the output of the map reduce.
Yeah. Whatever we took as a screenshot.
Yeah. So basically, the output was something like this, like country name and then the number of products sold in that country. So this sort of list we had as an output. And when we run our MapReduce job, like as you can see this in this other screenshot, it also has parameters like what were the input records to map process and what were the output records of the map process. So as we can see, we had the input was 999 records and the same was the output. Similarly, then we have something as reduce input records. So the output of mapper is going to reducer. So there also it's 999 records. And then we have reduced output records, that is 58. So because we have 58 countries where we sold our products, so it got reduced to 58. So this is the output we had.
So the name node is not coming up.
No, actually name node came up, but it was very slow. Like when I was running HDFS commands, it was taking a lot of time.
Okay, let's do one thing. Let's just stop it and let's run the Spark just in a distributed way by, okay.
Yeah.
Because that will kind of, even the Spark will take a lot more memory. I,
So basically, we can use stop all script to stop all the programming processes, that is name nodes, data nodes, resource manager, and node managers. And in a similar way to Hadoop, I've also installed Spark. So for that also, we get a tar file and we can download it and we can untar it. And I'll demonstrate how we can start the services.
How much time do we have? I think you should have got a bigger machine, Shivani. I think.
Yeah, this one is slow.
I'm not sure. I think more people would be using at this time. I don't know.
Yeah.
Shani, just open it in a different tab, like where you have this Spark setup.
Yeah.
Is it on the same host or it's a different client?
It's yeah, it's the same host. So here we can see that we have that Spark tar file, and here this directory we have the configuration related files in conf directory. So basically here also we have a similar slaves file. So it will have all the data node sort of thing, like which will be slaves. And then we can, along with Spark, we can run it in Java, Scala, or Python. So here I'll be demonstrating the one on Scala. So I'll use this start all script for starting all the services like master services and slave services.
Shwani, just to say, I think we are kind of gone above the time. I mean, if people are interested, we'll just kind of finish it. I think just one small example would really give them a good idea, is what we feel. So just let's kind of show one example.
Okay.
How much time it would take generally? Like when last time we did, how much time it started?
Yeah, it started. So with Spark Shell, we can start with Spark Shell, and I'll be demonstrating the same example, like the same thing which we did with the map reduce process, that getting the number of products sold in each country. The same thing we'll be doing with the help of Spark.
Taking a lot of time, Shani.
Yeah, actually, I read. Maybe more people are using at this time. That's right.
I mean, let's see how it opens. Can just put it on the presentation, right, where we had a snippet of it. Let's kind
Yeah.
of. So
Okay.
let's go ahead. Like, just explain.
Okay, so basically, our Spark shell looks something like this. So in the first statement, this var df, we are reading a CSV file that is sales Jan 2009, and then after that, the same thing which we did via MapReduce code. So if you look at this line, df dot group by country dot count. So like that same thing can be done just in one line, which we did like for which we needed a lot of code in MapReduce. So this is the same thing. Like we're grouping by country and then we are calculating the total count. And in Spark, we also have one more thing. Like let's say if you want to write Spark SQL like queries, so you can simply create df.create or replace temp view, and then you can give a view name. So now with the help of spark.sql, you can write any SQL query. So like we are seeing here, it's a spark.sql, select count asterisk from sales. So like here you can write normal SQL like queries for accessing your data frame. And then this is a Spark UI. So basically here you can see all the jobs, all the running applications that you're having and what are the jobs and stages of it and how many of them completed. And also SQL, like it will show a SQL like transformation, like what all is happening in the cluster.
You can basically see the DAX, like what are the different stages, like how the operation has been broken into multiple stages and tasks, and what is the computation time for each stage. And those are not sort of a statistics that you could extract with a MapReduce code. So Spark, in a way, is much more advanced in that. I think that's where I think a lot of people kind of still prefer using it. As we mentioned, right, you for each and every application, you'll see like if there is one set of executors which is running for a long, all these things can be taken care of. Shivani, just give a try if that Spark shell open. If not, I
Yeah.
think, yeah,
It's still opening.
let's just give a second. Anyone have any questions? I think let's just ask for questions. If let anyone want to know anything apart from this that you have a doubt. Okay. Okay, I think that's all we have. I think we map reduce word count example. How to put the sequence in reducer. So your point is in a map reduce word count example, how to put the sequence number in reducer. I mean, what exactly are you trying to refer? Do you want to have some sort of do you want to sort it? Is that what you're trying to say? Can you kind of be specific? Yes, you guys can kind of drop a mail if you have any questions. I can share my email address. If there are any queries, you can drop me a mail. I can kind of take a look at it and kind of get back. Um, I'm sorry, I think this got stuck. We never expected like this would be because we tried even in the morning. It was just running fine. For any things you guys can kind of check on my mail ID. I think I've shared. Shivani, if you also want to share, you can share. But yeah, uh, that's all we have. Any questions, you can just reach out there. Um, thank you. Thanks a lot. Yeah. Okay, guys. We will just disconnect. Thank you so much.
Thank you.
Yeah, we can use Hadoop on Windows. Initially, the plan was to kind of present on that only, but yeah, I think we thought like this will be much more useful.
Thank you, sir.
Yeah, sure. We'll disconnect. Thank you so much. Thank you, guys. Bye.
Bye.
Thank you. Hello. Hello, Shivani ma'am. Okay, I think session is over. I wish to express my sincere gratitude to Mr. Sudarshan Krishna Kumar and Ms. Shivani who demonstrated Hadoop nicely. Sir explains Hadoop Yan in a very easy way. All of us clearly understood the Hadoop ecosystem, Hive, Pig, HBase, MapReduce, Yan, HDFC, Spark, etc. Also, it throws light on cloud computing. The session was very interactive. I also would like to acknowledge our gratitude to all the participants who spent their valuable time and graced the session. Thank you.
ಜಾಸ್ತಿ ಮಾಡ್ಬಿಡ್ತೀವಿ ಬಡಜಿ ನೋಡಿ